All right, everyone, I have the top of the hour on my clock, so we are going to get started. So we have enough time today. Welcome, everyone. Thank you for joining me on this lovely Tuesday. Hope everyone is doing well. So we are going to talk about using the GEOWEB system on dams, dikes, levees, spillways, that type of infrastructure, and the flexible design solutions that we can offer. So I am Sam Justice. I'm your host today. I've been with Presto for nearly 10 years now after coming from the consulting world. I'm a licensed professional engineer with degrees in both civil and geotechnical engineering. I work pretty extensively with the ASTM and ISO committees in the geosynthetics industry. So I am one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through our extensive national and international distribution network, we offer both technical and site support, as well as free project evaluation services from our in-house engineering team, like myself. So a little bit about what we are going to be covering today. We're going to talk about the benefits of the GEOWEB erosion protection system, including how it can protect against material washout due to water flows in a variety of different types of project conditions. We're also going to talk about how geocells can accommodate some typical construction issues and design challenges, and how the GEOWEB system can help in these types of sort of niche applications where you know that you're going to have hydraulic flow, that sort of thing, potential overtopping of dams, that sort of thing. And where you're allowed to have a reduced vertical pressure on your subgrade, allowing for that reduced cross section if you are going to be driving vehicles over these types of systems. So lots of different things that we're covering, all handled by the GEOWEB system. A little bit about us, if you are not familiar with Presto Geosystems. Presto collaborated with the U.S. Army Corps of Engineers to develop the geocell technology in the late 1970s, and we've remained at the forefront of innovation in this market ever since. We do offer more than just a product. We are going to partner with our customers through the initial concept phase, all the way through construction to ensure that you have project success. Our worldwide distribution network is highly experienced, not only in the geocell technology, but other types of geosynthetics as well. And I really do believe that we have one of the most knowledgeable distribution networks available. So really a great resource to have on your side. And so our project assistance continues even after the product leaves our facility. We're not just selling you something and then disappearing. So we do operate in 4 main application areas when using the GEOWEB system. And that's going to be load support, where you're supporting vehicles, slope and channel protection, and then constructing green retaining walls. Presto also manufactures porous pavements, where we have both a vegetated and an aggregate surface solution, and lightweight reusable construction mats. But today we are going to be focusing on the GEOWEB geocells and how they can be really applied for the dam and levee, spillway, that sort of thing, construction. All right. Lost my button for a second. Here we go. So let's cover a little bit about the general information about GEOWEB geocells. So we're all on the same page. So the GEOWEB system has 2 main characteristics, and that the first one is going to be the cell, or basically the container size, the diameter, and the depth. So the cells do come in 3 diameters, basically a small, medium, and large. And then the cell heights are going to range between 3 and 12 inches. The actual cell size and height that you're going to choose are going to depend on your project specific details and your site conditions. Presto does offer a free evaluation service, which includes things like a written summary, calculations, cross sections, specifications, all the good stuff, regardless of your project size. And this evaluation is going to help you determine the appropriate cell size and depth for your specific project. Really, and to ensure project success, we're going to recommend against using things like standard tables or graphs, anything that you might see out there that is just sort of generic, because each project is unique and the needs of each project is unique. So choosing the absolute right best cell is going to be very important. Something else I want to point out is going to be the ultrasonically welded seam, and that's where it connects each individual cell wall, and that's going to be crucial to the functionality of a geocell. The stronger the seam strength, the better the geocell's performance. The GEOWEB panels are made from 100% virgin high-density polyethylene, HDPE, providing the strongest wall strength while maintaining semi-rigid ductile properties. If a cell wall is too stiff, it can actually overstress the seams and potentially cause seam rupture, which is as bad as it sounds. It is going to lead to project failure if that sort of thing happens. So I mentioned two characteristics. The second is going to be what you fill the GEOWEB panels with. So there are four main categories of infill that can be used with the GEOWEB system. And it's going to be based on the project type and the required protection that you're looking for. So the infill can include things like coarse sand, topsoil to grow vegetation, crushed aggregate, and concrete. And so this will often allow for the use of on-site materials, potentially reducing or eliminating the need to import fill to your site. And so we can help work with you to determine the most appropriate infill material, especially if you do want to use your on-site material. We can review gradations, anything like that, to see if it is going to be appropriate and if it can be the most cost-effective solution. And that's included in that project evaluation service. All right. The GEOWEB panels, as I mentioned, are manufactured from that proprietary blend of high-quality virgin HDPE resin, and it has proven its durability over the past 40 plus years. So the GEOWEB does not contain any fillers. There's no things like calcium carbonates, recycled materials, or polymer alloys. The GEOWEB system is designed to last over 100 years, with lab testing showing it can withstand up to 149 years before there's any sort of carbon black degradation, even with continuous 24-hour sun exposure, which one, sun's not out for 24 hours, and we haven't quite gotten to 149 years yet. We're somewhere in the low 40s, but we are getting close. So we stand behind our data, ensuring that you confidently can build with materials that you trust. All right. And like I said, the GEOWEB panels and all of our accessories are made in the upper Midwest, so 100% made in the USA under strict quality assurance and environmental control processes. So they comply with all the requirements in the Build America, Buy America, and the Infrastructure Investments and Jobs Act. So if you are looking for sort of any federal dollars or on a government project, anything that says it needs to be made in the USA or built in America, these products are going to meet that. Nothing is, imported from overseas, anything like that. And one of the reasons that Presto Geosystems offers the world's most complete multi-component cellular confinement system, our GeoCell, is that we back our innovations with accredited research and testing, and have done so since the creation of the GeoCell technology in the late 1970s, which again was by us. And that is with industry-leading GeoCell researchers from the US and from around the world. And so we do this continually. We have research projects happening right now. So we are continuing to try and make sure that this is going to be the most effective solution for the types of projects that we offer. So this is definitely something that you can trust. It does have research, testing, and real world experience backing it all up. And we do have active participation in a number of different geosynthetic committees to uphold the integrity of our industry, including ASTM, AREMA, AASHTO, TRB, ISO, and IGS, just to name a few. All right, with a little bit of background, I mentioned things like accessories and components. So let's talk about those as well. So the system components are all of the supporting pieces that make the GEOWEB the most complete geocell system and ensure that you have a uniform performance of your interconnected system, protecting against damaging effects of non-uniform deformation or differential settlement when you have applied load. So for load support applications, the Atra key is going to be the most crucial component for a fully integrated system. The Atra key connects the GEOWEB panels into a single web and significantly speeds up the installation. Made from that durable HDPE plastic, they are going to last the lifetime of your project. Atra keys ensure that the panel remains securely connected and that the GEOWEB system is not going to fail under anticipated loads. Their specific engineering values guarantee the system's durability over time and avoiding the corrosion that you would see with things like metal staples or the failure of underperforming cable tie systems. And here you can see what that attrokey looks like as it's going in. It's connecting all of those webs together to cover your entire project area. And this is just sort of a close-up of what that attrokey looks like. You can see that it actually has what we call frictional barbs, and those are designed to interlock with the GEOWEB textured cell wall. And these barbs are a recent innovation to the attrokey. Collectively, all of our features provide additional protection against the three main primary modes of mechanical junction failure. And those are going to be shearing, splitting, and peeling. Additionally, we also evaluate the factor of safety for the attrokey connection in all of our project evaluations. And so as you are going through, if you're looking at the GEOWEB or any other GeoCell that's out there, it's crucial that the manufacturer provides calculations to verify the factors of safety for all of those primary modes of panel connection failure, and it's based on their specific panel connection method. We're the only ones with the attrokey. Other GeoCells use different methods, so you need to make sure that everybody's evaluating on what they're actually going to use. All right. Next, we have a couple different anchorage options. And so this is for when you are going to put the GEOWEB panels on a sloped surface. If it's flat, you actually don't need to anchor it. The GEOWEB panel is going to sit there. Gravity is going to do all the work. You're good to go. But if you're on a slope, let's hold it in place. If it's a relatively shallow slope, you can use stake anchors. And so this can be either metal stakes, just a standard piece of steel rebar, or we do offer our Atras Speed stake. And so this is a molded HDPE stake, so there's no metal to it. This is really helpful in corrosive environments. Maybe you're along a coastline and salt water that could corrode metal. If you're doing something in an electrical substation, let's say, you don't want to have any metal because that's a touch step potential, very dangerous. So there are applications where having that completely plastic stake is really important. And so this is a stake that replaces metal. It's just as strong. It has those barbs to help hold it in place. It's not going to bend or twist, anything like that. So that is definitely an option. The other option, especially if you are in a steep slope environment, say like a 1-to-1 slope, we have tendons. And so tendons are basically polyester strands that are run through the GEOWEB panel and then anchored at the crest to say a dead man anchor or earth anchors, rock anchors, something like that. And we have our Atra tendon clip, which is our load transfer device. So it's a special device that helps transfer the load from the GEOWEB panels to the tendons to that crest anchorage. So both of those are valid anchorage options. You would do one or the other. You don't necessarily have to use both at the same time. It can be a little bit of overkill. And our project evaluation service can help you determine which one is going to be the most appropriate and make sure that you have something that is actually going to support the load, that you're not going to see, the whole panel just slide down the slope, 2 years after installation, something like that. You wouldn't want that at all. So definitely something that's important to make sure you get determined for your specific project and don't just, try and base it off what maybe you've done before or what somebody else said they did, that sort of thing. All right. Now, let's talk about some application-specific uses of the GEOWEB system. That's what we're here for today. So let's get started on that. So typical earthen dam. We've all seen one of these. It's going to look something like this. You have your wet side. You could have GEOWEB armoring there. Typically, you're going to see aggregate or concrete infill on the wet side. And that's going to, because, grass is not going to grow if it's all wet all the time. But it can depend on if you've got wave action, what your drawdown rates are going to be, anything like that is going to determine what you have on that side. And then on the dry side, typically you're going to see vegetation. It's going to be a nice grassed embankment. It's going to look very nice. You can have grass on the wet side. You can potentially even do a mix. You can have it be stone below the mean water level and grass above the mean water level, something like that. And then you can have the GEOWEB go across the crest as well. And this could be if you have an access road, that's pretty common on top of those sorts of embankments. the GEOWEB can help support those vehicle loads as they're going across. And that can be filled typically with stone if you're going to have vehicle access, but grass can work as well. Again, just depends on what you need at your specific site. I do want to sort of talk a little bit about what it means to drive on the GEOWEB system, because I did say it could, stabilize the crest of those dams, make that drivable surface. And so the GEOWEB is a 3D confinement system, and it operates by distributing vertical cyclical load. So those car tires as they're driving across. So when that vertical load is applied, the active earth pressures within the loaded cell are going to push against the passive earth pressures in all the adjacent cells supporting the load. So each cell basically supports the one around it. And as I mentioned, the GEOWEB system is actually pretty effective, even with things like sand or on-site sort of recycled infill, something that maybe doesn't have the greatest quality, but it can still work really well with the GEOWEB system. And so the way it works is it quickly redirects your vertical loads horizontally to engage the cell walls and generate hoop stress within the loaded cell. And so this ability to disperse the load distribution angle is pretty crucial to actually maintaining the system integrity. It's what we call the mattress effect. Kind of acts, you could also call it the snowshoe effect. It acts like a snowshoe. It spreads your load out over a wider area with less pressure over that wider area. And so the strength of those internal seams, that ultrasonically welded bond that I mentioned, the panel connection method, which again, we use the Atra key, and then also the increased load bearing capacity through that mattress effect are going to be key factors in enhancing a geocell system's performance. And so GEOWEB confinement prevents lateral shifting of your infill material, reducing or even eliminating the rutting at the surface and controlling overall differential settlement. And I just want to sort of show this because this is a great way to sort of visualize what that mattress effect is. So you have your unreinforced section on the left and then the GEOWEB reinforced section on the right. And you can see a pretty dramatic difference in that stress bulb. On the unreinforced section, you have all the way up to your highest levels of stress, and it's got a pretty typical steep angle. So the bulb is relatively narrow and quite deep. But with the GEOWEB reinforcement, one, you've reduced your highest stresses. We've completely eliminated the red and orange stress level of this admittedly unverified graph, but it also spreads that load out significantly wider. And that's because of the hoop stress within the GEOWEB cells. So you're having less stress over a larger area. And so that's a really great way to sort of visualize what's happening as you're driving over the panels. You can see what's happening on the ground. And a couple of benefits to using a GEOWEB in an unpaved road situation include reducing your cross-section thickness, usually by a pretty significant amount. Usually we're seeing around 35 to 50% thickness reduction. And the GEOWEB panels can help prevent rutting and uneven settlement of the aggregate by controlling and stabilizing the movement of that stone when it's being driven on. The stone is being held in place by the individual cells of the panels, so they're not getting pushed down or pushed to the side by those car tires. And that stress reduction and the stress spread is going to help keep the roadway in place a lot longer without repetitive maintenance. And roadways and drive access is great, and it's definitely a great benefit from the GEOWEB system. But what we're really talking about today is how it can help with dams and other hydraulic structures with the erosion control benefits on the slopes, both wet and dry slopes. And so the GEOWEB is an economical alternative to large riprap or reinforced concrete on those dam faces or spillways, and can allow for vegetation on those faces that otherwise it would not be possible due to the hydraulic forces at play. So if rock is used, GEOWEB allows you to greatly reduce the rock size. And if you use concrete, we can actually cut the required concrete depth by as much as half when compared to reinforced concrete solutions. So this is just sort of a very basic diagram of what a GEOWEB would look like in a slope protection method, which is basically what a reinforced dam would be. So this is a pretty typical section. It can show you, you have your GEOWEB laid out, you have your two different anchoring options. You can do the stakes that we mentioned, or you can do the tendon. In this case, it's tied off to a dead man anchor. Again, those are an either or. You wouldn't do both at once, but they're just shown here for, ease. And then you can either vegetate, fill in with stone, fill in with concrete, all that good stuff. And the cellular network, so all of the individual cells of the panel, basically create little mini faux check dams, but they protect the upper soil or aggregate layer from those hydraulic erosive forces. And they can basically hold everything in place so that you're not getting rills and gullies being formed. Everything's being held there, even as you have that hydraulic flow over the top of the panels. And with the GEOWEB vegetated option, that topsoil, when it's confined into the cells, can actually withstand some pretty significant velocities and shear stresses, and potentially replace the use of riprap. And so we're going to talk about that a little bit more in a second, but this is probably one of the most common things, and one of the greatest benefits of the GEOWEB system is allowing for the use of vegetation in areas that otherwise might not be able to support it. But like I said, you can fill in with stone and concrete. This is great if you know that you're going to have really high flows. Concrete can handle pretty much any water flow. We all know that. But so this is definitely an option. I don't want you to think that it can't handle these, just because we are going to talk a lot about filling in with topsoil. But I mentioned, and I want to sort of reiterate, we do a significant amount of research with the GEOWEB system. We are not just throwing these products out there and saying, hey, good luck, it'll definitely work. We have the backing to prove that these things are going to function the way that we say they will. So one of the biggest tests that we've done was at Colorado State University. It was in Fort Collins. It was under the direction of Dr. Chris Thornton. And Colorado State University is considered one of the top hydraulic research facilities in the world. And it's actually got a pretty unique facility. It's located underneath the Horseshoe Reservoir and has a couple 100 feet of static head, and can achieve one of the highest velocities and shear stresses in their test flumes anywhere in the United States. So the GEOWEB system was tested at CSU in a couple different scenarios. So we started with topsoil and vegetation testing. So in this case, this was our 6-inch deep GEOWEB panels, and was filled with topsoil and was covered with a TRM, turf reinforcement mat. So we did allow for that vegetation to get fully established, and it started to go across. And the ability to withstand high velocities and shear stresses are the main thing that we're thinking about when considering withstanding water flow. And the second objective that we had was also to compare the performance of topsoil filled GEOWEB with riprap or other conventional solutions, such as an erosion control blanket, independent of any other system. And so this is sort of a quick summary of what that looks like. And it really showed some pretty amazing results. The GEOWEB system withstood a 29 FPS velocity and 16 pounds of shear without failure, more than twice the hydraulic resistance of 12-inch riprap, about double the performance of a high-performance TRM alone. And it works because the GEOWEB system provides cover for the soil, so there's no scouring, and confines the soil so it doesn't get washed out over time. And we also tested it in unvegetated conditions, so before that grass took place. And in that case, we did add a TRM, that turf reinforcement mat, and it still improves the hydraulic performance of a TRM individually by about 30%. So it definitely is just by far and away much better than conventional methods, I would say. We also tested our aggregate infill, and the high number of data points, testing 3 different cell sizes, 2 different rock sizes, all sorts of stuff, allowed us to create a regression equation. And the main objective of the aggregate testing was to determine how much the 3D confinement can aid in reducing your stone size. So we looked at how well the aggregate stays in place during the tests, to determine the rock size that would prevent washout, because the system just doesn't work if the individual stones keep getting picked up and washed away over time. And so the results were pretty impressive with the GEOWEB system, working on a steep bed slope and allowing for those high velocities and high shear stresses. The vegetated system we just saw could handle around 30 feet per second. The GEOWEB filled with stone can handle around 16 feet per second. So a little bit less, but definitely compare, picking up an individual rock and getting that washed away versus ripping out grass and scouring a bunch of topsoil. So slightly different things that we're looking at there. But really the main objective was to determine the reduction in riprap size due to the GEOWEB system. And it was a significant reduction, anywhere from 2 to 10 times the size. Typically with the GEOWEB system, we're looking at anywhere from 1 to 3 inch rock. So that's much, much smaller than 12, 16, 24 inch sized riprap stones. Then we also did concrete testing. So the concrete is actually poured in place with no additional formwork or reinforcement necessary. The GEOWEB cell walls act as the form for the concrete. And so confinement in this way also allows for the use of easier to place higher slump concrete and ensures that you're going to have that uniform concrete depth. You're not going to have slumping down to the toe where it's thicker at the toe and too thin at the crest, that sort of thing. And generally, a 3-inch concrete filled GEOWEB panel can replace a 6-inch reinforced concrete panel. So just something to keep in mind. But we actually did max out the flume at Colorado State University at 36 feet per second. The water actually just overtopped the flume and it couldn't get going any faster. So we've seen in the real world flows significantly higher than that, but that is what the research shows because that's as much as the flume could show. But basically, if you are going to be in a situation where you're going to have very, very high flow velocities, concrete is going to be the way to go. And then once as I mentioned, once it's anchored, the GEOWEB can actually just be poured. The concrete can be poured directly into the GEOWEB panels. So just take it directly from the concrete truck, pour it into the panels, drag it all down, make sure everything is nice and filled, screed it flush with the top of those panels, and you are good to go. And the system is actually still pretty flexible. And so we do consider it a flexible concrete mat. So if you wanted, it's not super practical, but you can actually pre-fill the concrete and then move it into place later if you want to. Typically, it's easier to put the panels directly on the slope face and then fill them in from there. But sometimes people have specific installation steps that they need to follow. And this is one of those benefits to a flexible system is that you do get a flexible concrete mat. And so, like I said, here are the results of that testing, maxed out at 36 feet per second. But it is going to be basically able to withstand any type of water flow or shear stresses that are going to be coming over this. So if you are going to be in an overtopping situation, maybe, you're going to have really turbulent flow, anything like that, concrete is going to be a really good option. And one of the benefits is you can do a small section in concrete where that overtopping might go, and then do stone or topsoil around it. So you don't have to concrete your entire dam face if you don't want to. You can do a small spillway section and still have the rest be, more of a soft armor solution. All right, let's show some case studies. Everybody likes to see these things in the real world actually working. Nobody wants to be the first one to do something, right? So let's see how this works. So our first one is going to be Lake Overcup Dam. This is in Arkansas. It was a popular fishing hole and nature retreat, so very popular with the public. Lots of, small vehicles, so your cars, pickup trucks, things like that, and pedestrian loads. And so this dam was actually a man-made dam. It was created from a mile-long earthen dam that had been built in the 1960s. The dam foundation was on native clay that had over time moved and settled and was causing some structural integrity issues to the dam. They'd had years of noticeable structural instability, including multiple slides that they had just sort of patched whenever it happened. And so the Arkansas Game and Fish Commission wanted to do more than these quick fixes. They wanted this long-term solution that was going to move with the dam because they weren't going to be able to fix the clay foundation. So as the dam moved, they wanted a flexible solution that was going to move with it, that didn't constantly need to be come back and fixed. So in 2022, Presto Geosystems was able to provide a system that would repair those superficial slides along that dam face, and then also repair and stabilize the levee access road on top of the dam that people were using to drive on. So in this case, all of that vegetation was removed, as well as any remaining riprap from all those temporary repairs that had happened. The dam slopes were regraded to a gentle 3 horizontal to 1 vertical, making a nice, easy working surface for the placement of those panels. The access road is also along the top of the dam. You can see that, can't really see it, but no, it's on the top of the dam in these pictures here. And that was cleared and regraded as well. In this case, a non-woven geotextile was placed along the slope as a separation layer, and that was required per local regulation. And so that's something that we can easily accommodate if you have anything that says, our local regulations need X, Y, Z. That is good to go for us. We can incorporate that with the GEOWEB system. It's definitely something that's nothing new under the sun. We have seen all sorts of weird requests and are easily able to accommodate those. In this case, the geotextile also extended up from that slope face across that access road on the top of the dam structure, and that just helped ensure that the roadway would be stable on the crest, make sure that there wasn't any issue. If a vehicle got a little too close to that crest edge, there wouldn't be any sort of crumbling or loss of the roadway at the top. In this case, they chose the 4-inch deep GEOWEB panel, and they filled those in with topsoil. And here the panels were anchored with the Atras speed stakes. Those were the 100% HDPE stake, that molded plastic stake. This is a really great choice in this particular case because they aren't going to corrode or degrade in the environment. So if they get wet, if they're around corrosive soils or anything like that, nothing is going to happen to those HDPE stakes. They're going to stay strong and stable the entire time. But so they were easily able to put those in. Again, this is only a 3-to-1 slope face, so pretty easy to work on. Filled that all in with topsoil. And then this is what it looked like the next summer in 2023, so about a year after installation here. So the grass is fully grown in. You don't see the GEOWEB panels anymore, but the protection is still there. And so that access road where the 2 people are actually walking there is going to be significantly more stable. It's going to allow for vehicle access. You can now drive on top of this and not have to worry about it constantly rutting or damaging the dam, anything like that. And now if there is any overtopping of this dam, it can flow over the top of the GEOWEB panels, down the GEOWEB protected slope, and you're not going to have soil washout, erosion, anything like that that would need to be repaired. So a great solution for them. Okay, we have another case study here. This is the Patch Reservoir Dam. This one's in Massachusetts. And so this was an initial structure that was built in the late 1800s. So just a little while ago, and unsurprisingly, no longer meets the Massachusetts standards for dam safety. So initially the plan was to basically remove this dam entirely and redirect all of the water out of this area, but residents fought to keep the dam in place. So a solution had to be found to bring that dam spillway and the access road into compliance, as well as stabilize the embankment above the dam training walls. So potential conditions included design flood conditions, overtopping, and erosion control during both normal and flood operations. And additionally, the roadway needed to be upgraded to support heavier vehicles because initially, again, late 1800s, slightly different vehicles than what we're driving now. So they wanted to make sure that roadway could actually support maintenance vehicles, potential emergency vehicles, anything like that. So some of the original wall structures were maintained, mostly for aesthetic appeal at this point. They weren't really doing a whole lot for the actual dam structure. So the majority of the area was regraded and rebuilt to meet those current safety standards. The dam embankments were graded to a 2 horizontal to 1 vertical angle, and that was about the steepest that could be accommodated by the GEOWEB system for what they were trying to do. The GEOWEB system can go on a significantly steeper slope. It can go up to a 1-to-1, maybe even a little steeper, maybe 55 degrees, we would say is max. But for what they were trying to do in terms of the hydraulic flow conditions and the site constraints, that 2-to-1 slope was about the max they could do, which they weren't able to do without the GEOWEB system. So that's a great thing that the GEOWEB system was able to do, is get that slope a little bit steeper and minimize the footprint as much as possible. And so in this case, they again filled it with topsoil. In case they went with a 6-inch deep GEOWEB panel filled with that topsoil and vegetation. They also added a long-term turf reinforcement mat over the filled panels just to help prevent that erosion as the vegetation becomes established. Stakes were also used here on that 2 horizontal to 1 slope. So that's something that was pretty easy to install. This is not a super tall slope. So they weren't working with a whole lot of, steep area that they needed to cover. But it also helped make sure that they minimized the amount of excavation that was necessary on site. And so no large equipment or anything was needed. This was all able to be placed by hand, and small equipment made it pretty quick and easy. Some riprap was also added to the area where there was some potential for turbulent flow and debris impact based on how the water was flowing to and over the dam. They had seen repeated impacts to a small specific area right in front of the dam face. And so they added this riprap to that area just as a little bit of extra protection. They were able to just put that right over the GEOWEB panels. And so this isn't always necessary or even usually necessary, but it does go to show how the GEOWEB fits in with specific project needs. They knew they had a specific area at this site that had seen repeated debris impact, and they wanted to protect it. And so this is something that was easily able to be accommodated when using the GEOWEB system. So, if you know that you're going to have areas of rough water, or if you know that you need to accommodate animal habitats, anything like that. These are things that are easily handled with the flexible GEOWEB system without having to do significant design changes every single time something new comes up in the field. So it's really just one of the great benefits of avoiding things like precast concrete structures, which, once it's there, that's the option you have. This is a great way to have flexibility in your initial concept phase all the way through your construction. And then the other area I had mentioned that the GEOWEB was placed along the roadway. And so this roadway was completely rebuilt to be able to support maintenance vehicles and emergency vehicles to the site. And because the access road was in the overtopping area, the GEOWEB system was used to help stabilize the stone and prevent washout during those flood events. So the research that we had done at Colorado State University, it basically showed that required stone size that was going to be necessary for this specific project. And it was based on the hydraulic flows over the roadway. And again, for this project, not just generically, not being overly conservative, anything like that. So we were able to get the stone, as small as possible so that it wasn't some big engineered stone they had to get. And so this way we know that it's going to hold up over time. We know that as that flow happens, this is going to be protected and held in place. All right, one last case study here. This was an impoundment pond in Florida. And so they were looking for a solution to be able to drive over the crest and the bottom of the pond for maintenance issues. So they knew that the water was going to be both raised and lowered quite frequently. And so they were going to have some pretty significant drawdown effects if they had to use something like the local sand. This was the dam is built on the pond, was built on a sand floor. And so they couldn't use their sand because as the drawdown would happen, it would just constantly pull all of that sand away. So in this case, they went with a concrete filled GEOWEB, and they were able to do that both for the slopes, for the roadway across the top, and even a little bit of the pond floor. This made it really easy for a smooth, drivable surface. Again, they use that 3-inch deep GEOWEB, makes it really simple, nice thin piece of concrete that can support those vehicle loads. and any sort of hydraulic flow or drawdown effects that are happening aren't going to have any negative effect on the GEOWEB system. And then last sort of thing that we want to cover is spillways. Slightly different than just doing dam embankments, same concept, but this is an area that is going to have a significant amount of flow over it, as opposed to sort of hoping it doesn't overtop, but designing as if it will. So this was a spillway at a medical complex in Tallahassee, Florida. And so it was going into the detention pond. So they was collecting water from all across the medical complex and directing it into this area. And so this was a relatively small flume, but it covered both the flume and the spillway apron into the detention pond. And so, like I said, it captures it from the entire 82-acre runoff area. This is another spillway. This one was actually at a country club in Pennsylvania. They decided to do concrete for this one, so they were able to do this hard armor spillway and pour the concrete directly into the center of the GEOWEB panels, and then do topsoil on the outer edges to sort of feather it in and make it blend into the rest of the surrounding green area without that hard edge. And so it was really nice that they were able to just pour directly where they wanted it to into the concrete panels and be able to go around curves, go up and down as the grade changes, all of that good stuff. And then you can see as it's there. So small little section that's being armored, that's being protected. This way, as the water flows through, they don't have to worry about constantly having to come back, fix any erosion issues, make sure that this spillway is still holding up and can withstand water flow through it. That concrete is going to be good to go for decades. All right, so that's my show today. So in summary, the GEOWEB slope protection and load support systems can help protect your structures for erosion due to water flow, extreme events, vehicle loading, all that good stuff, reducing your lifetime maintenance and repairs. The variety of infill materials and different installation applications make the GEOWEB system a good fit for a lot of different project conditions and can help solve and mitigate typical construction issues. Additionally, confining the material and reducing the stress can potentially decrease the overall thickness of your cross section while still giving the structural integrity that's required. We do offer our comprehensive system solution for dams, spillways, levees, and other hydraulic infrastructure, and our recommendations are tailored to specific project details and conditions. I've mentioned it a number of times this last hour, but we do offer our free project evaluation service, and this is for all projects, all sizes. And these evaluations do include things like supporting calculations, CAD details, specifications, research summaries, case studies, all of those good things that you would want to put into your bid package, show your contractors, etc. So to get started, simply fill out the form on our website, providing as much information as you have, and attach any relevant documentation, things like geotech reports, site photos, if you've done any preliminary CAD work, anything like that. And just remember, it's really important to not rely on tables or graphs or word of mouth, as each project is really unique and requires a site-specific solution. But the evaluation service does come usually within 3 business days, sometimes sooner than that even. So this is not a long-term thing. So even if you are looking for something with, hey, we're out doing construction next week, but is there anything we can do to make this better? We can get something back to you a lot faster. We can get those sorts of things out to you very quickly. And we're going to work with you to get the best solution for your project. We're not just selling one thing and saying, hey, good luck, make this work. We're gonna make it work for your needs. And we do deliver quality and over 40 years of expertise. We guarantee each shipment meets or exceeds our specifications, so you can deliver certainty and build with materials that you can trust. No disclaimers, no fine prints, no squirrely sales tactics. All right, a little bit of housekeeping. You are getting a PDH certificate for listening to me today. So if you listened live on May 19th, whatever today is, you are going to get an email from GoToWebinar. You'll get that by the end of the day, and that will show you your PDH certificate. And then by the end of the week, you're going to get another email, this one from Presto Geosystems, directing you to our webinar dashboard, which you see here. This webinar is being recorded and it's going to be put up on the dashboard along with our library of other webinars that we've hosted in the past. You can get PDH certificates for watching those as well. So 2 emails, one from GoToWebinar by the end of the day, one from Presto Geosystems by the end of the week. So if you don't see those, feel free to reach out to us. But as always, check your spam folders, all those good things first. And definitely check out the dashboard. A lot of good stuff on there. We got a lot of things that are going to be really helpful for you to look at, case studies, videos, installation packets, that sort of thing. Lots of good information on there. All right. So thank you so much for listening to me today. My contact info is here on the screen. Definitely reach out to me. I love hearing about the types of projects that people are working on. I'm always here to help with technical questions, whether it's, hey, we're just starting to look, is this something that could even potentially work for our site? Or you're ready to get into the nitty-gritty details right away. Anywhere you're at in your project, definitely feel free to give me a call. More than happy to help out with all of that good stuff. GEOWEB is not going to be the right solution for every single project, but it is going to be a good solution for a lot of projects. And even if it's not, like I said, we have an incredible distribution network that's really knowledgeable in all the other geosynthetics that are out there that potentially could be as good or a better fit. And so I'd be happy to connect you with them as well. So yeah, definitely feel free to reach out to me. I am going to do a bit of a Q&A here. I see some great questions have come in, so I want to answer those. And the Q&A is going to be recorded. So if you do need to drop off, totally understand. Have a great rest of your day. Come back to the webinar dashboard when this is thrown up there, and you'll be able to get to that Q&A session on the recording. Otherwise, if you have time, feel free to stick with me here, and we can get to some of these questions. Let's see here. A lot of questions about how do you know that you're reducing the thickness of your roadway? So we mentioned that we saw how that can be anywhere between like a 30 to 50% cross section reduction. And we actually have our calculations using approved AASHTO methods showing what the section thickness needs to be based on your anticipated vehicle loads, your subgrade soils, all of that good stuff. And so we can show how the inclusion of the GEOWEB system into that section can reduce the overall required thickness to support your vehicle loads. Like I said, typically you're going to put in something like the 4 or the 6-inch GEOWEB for a load support application. That's going to be pretty common. And so you're going to be able to go from, maybe a 12 or 14-inch section down to an 8-inch section or a 6-inch section, something like that. So you're going to get that pretty good reduction in depth, but then you can also use, like on-site materials if you have those. So that can be a great savings as well in terms of material cost. You don't need to get a specific engineered stone if you can reuse the maybe low quality but abundant material that you have on site. So things like that. Some questions about dealing with cold weather environments. And yeah, so that's definitely a thing. These are, the GEOWEB system has been placed in every state in the US. It's pretty extensively across Canada, Northern Europe, that sort of thing. So very cold weather environments. And so if in terms of like, if you're putting it on the wet side of a dam, and so you're worried about, if your pond or your lake or anything freezes, what is that going to do? And so that's a great question. So with the GEOWEB system, it can actually withstand those temperature changes. There's not going to be any degradation to the panel itself. It's not going to change how the system functions or how the system lays on the embankment. And then in terms of if your pond freezes, it can freeze up to and against, and be like the GEOWEB panel can be included in that freeze, and it's not going to damage it. And then if you do have, in the spring or even in the winter, if you're having ice shove, that's a pretty common thing on like I'm in the Midwest, so I see the Great Lakes. That's a pretty common thing here, is to have ice shove, where you have those big, ice blocks being pushed up onto the embankment. And so the GEOWEB panels can actually, withstand that happening. They're not going to be damaged by ice shove. And so the ice basically rides on top of the panels and can slide up over them as that happens in the winter and the spring. Without damaging the panels. It's not going to like rip them out of the ground or anything like that. So we do recommend, if you are in an area that is going to see a lot of that sort of action, maybe go check it out in the spring. Make sure nothing extreme has happened, but we don't anticipate and have not seen that be an issue in the past in our cold weather applications, which we have done quite extensively. Some questions about the Atris speed stakes. So those were those plastic stakes. Basically, how are they installed? Are they actually going to be strong enough? That sort of thing. And so they are pretty easy to install. You can either hammer them into the ground directly, or you can do like a mechanical hammer and drive them into the ground. So either way, that works. In terms of their strength, they are a really rigid molded plastic, and they are quite thick around. They're about a 1/2 inch diameter, so same as like a number 4 rebar size. So they're not like a little twig of plastic or anything like that. So as you are driving them into the ground, if you're in a really hard soil, like if you're in like a hard pan or really compacted clay, they can be driven into that. If you were to hit something like a rock or just some layer that just is not going to be driven through, it's not going to damage the stake itself. If it's a rock, it'll sort of either move the rock out of the way, or you have to dig that rock out and then drive through, same as you would with like a steel rebar stake. That's not any different. And if you're trying to like drive into like a shale or like a rocky ground, you are going to have to, drill into that first and then put the stake in. It's not strong enough to drive through bedrock or anything. But it is strong. It is quite strong, and it can go through really any type of soil. It's going to be strong enough to do that. It is not flexible. It is not flimsy, anything like that. We designed it well. I'll say that. Let's see, any options or recommendations for the subgrade preparation, both on the slopes and on roadways. And so there isn't a lot. One of the benefits of the GEOWEB system is that you don't have to do extensive subgrade preparation. Really, you're just trying to remove anything at the surface. So strip off vegetation. If there's large boulders, like with the Lake Overcup Dam, there was riprap in a couple places where they tried to patch it. You're going to want to remove that. But then you don't really have to do more than that. And even with roadways, you don't have to like chemically treat the base. You don't have to do over excavation and fill it back in with road base or anything like that. You are working with just basically the soil that's there, and then the GEOWEB system gets put on top of that. If you're in a very soft soil environment, not really something that you're going to see at a dam necessarily, but in terms of just like load support, we do see it semi-frequently where people are trying to build on very, very soft soils, mucky, oversaturated. That's something that we can talk about on a sort of project-specific basis on how to support those. But in general, no, there's not a lot of subgrade preparation that's necessary. That's necessary. It really is just strip the vegetation, grade it to what you need it to be, and then you can place the GEOWEB system. Let's see here. I will do another question here. do you have an approximate maximum slope for the GEOWEB, and do different fills make a difference? So yeah, the maximum slope that the GEOWEB system can handle is around 55 degrees, so a little steeper than a 1-to-1. When you start getting steeper than that, you're going to lose material no matter how well it's confined in the GEOWEB system. That's just, it's really getting too steep for that. So about 55 degrees is going to be your max. In terms of different fill materials, that's not going to have a significant impact on that slope angle necessarily, unless you have significant hydraulic flow. So I'm going to change my statement. Yes, the slope angle can change based on your infill if you have significant hydraulic flow. If you know that you're in a dry environment or something that really is only going to see like rain falling on it, but not like a spillway structure, dam overtopping, something like that, you can go quite steep with any infill. If you know that you're in a spillway environment or somewhere that's going to see fast velocities, then you're going to be more limited in what your slope angle can be, just because that flow, the steeper it gets, it's easier for the material to get washed away, even within the GEOWEB panel. Typically in hydraulic environments, we don't want to go steeper than a 1.5-to-1, so about 33 degrees. Is where we sort of try and max out. We have done steeper, so I'll say that. A lot of times you need to go concrete in those situations just to be able to withstand the velocities. But again, project-specific basis, definitely reach out. I love seeing those types of challenging projects where, nothing else is working. We've got to come up with a solution. What can we do? I'd love to be able to figure out what those are going to be. So yeah, I guess there's not a specific answer, unfortunately, but again, that's where we're saying don't rely on tables to say, oh, in this slope degree angle, this is what you have to do, because it's never as easy as that. I hope that makes sense. Some questions about the geotextiles underneath it. Do you have to use a geotextile? Does it have to be a non-woven geotextile? So no. So I know the case study, the Lake Overcup Dam case study, used a non-woven geotextile. That was a project-specific requirement. That was not something that Presto Geosystem required. That was something that Arkansas required. So it's not something that we're going to recommend every time. We wouldn't recommend it for every single project. And if you have different requirements or you have different experiences, maybe I've had bad experiences with non-woven geotextiles. I don't like them. I like to use woven geotextiles, or I want to use GeoGrid, something like that. Those are things that we can incorporate in our project evaluation service. But that geotextile layer is not a requirement every single time. It is something that we evaluate again on that project by project basis and determine what is necessary for your needs and what's appropriate for your site. A non-woven geotextile is not appropriate for a highly clay environment. They get clogged, they create, water barriers, they get very slippery in those sorts of things. Those aren't great. We wouldn't want to do that in a clay environment. In a sandy environment, not as big a deal, not as much concern there. So definitely don't think that you're being required to use that sort of thing. So that geotextile layer is if it's necessary, and if it is, we can give our recommendation for it. All right, I'm going to do one more question because we are running out of time and I want to get you back to your day. Is there, can you do paving over the top of it? We didn't cover it today, but a couple of people have asked about installing asphalt over these. And so, yes, you can put asphalt on the top of a GEOWEB system. You would fill the GEOWEB panels with a sand or a stone, some sort of granular material, and then you would pave your asphalt on top of that. You wouldn't put asphalt in the panels, if that makes sense. The asphalt would not be your fill material. But it would be essentially like a regular asphalt installation where you have a granular base layer and then your asphalt. It's just that the granular base is confined within the GEOWEB panels. And you can pave concrete on top of the GEOWEB panels if you don't want to fill the GEOWEB with concrete. You again can have your granular base confined within the GEOWEB panels and then pave concrete on top of that. So those are really popular for roadway systems. Access roads are common for that. So if you need to pave your way out to your dam or spillway or anything else, or if you're not working at a dam or a spillway at all, but you need an access road somewhere, yes, you can do your standard paving methods on top of the GEOWEB system. And the GEOWEB basically acts as the base support for that pavement. So I hope that helps. But I've run out of time today. Thank you, everybody, for your time today. I really hope that you got something good out of this webinar, and I hope I hear from you soon. And look out for those emails. One today from GoToWebinar, and one by the end of the week from Presto Geosystems with the webinar dashboard information. So have a great day, everyone, and I hope to see you again soon.